In section 4.3, we covered two more ways to prove triangles congruent. If you understood how SSS and SAS worked from the last section, then this section will be a breeze. First up is the ASA postulate. This theorem is named like the two theorems from the last section that also prove triangles congruent. Given that, you can probably guess what ASA stands for. Angle, side, angle. You could probably get pretty close to the formal definition too. Pretty straightforward if you understood the section 4.2 material. Let me go over the next theorem quickly before talking about these two in more depth. Here's the AAS theorem. It's the first one that's a theorem instead of a postulate, and you should know the difference between those two things by now. AAS stands for angle, angle, side. You probably didn't need to be told that at this point. Here's the formal definition. This probably isn't much of a surprise either, but the one new piece is it has the word non-included in it instead of included in the definition, because that side that you match up has to be one of the sides not in between the two angles that you match up. Together, the ASA postulate and AAS theorem give you complete coverage for two angles in one side. If you can match two angles in one side of two triangles, then the two triangles are definitely congruent as long as the sides are both included or both non-included. The trick is why, and it all comes down to the location of the side. If the matching sides are both included sides, then the reason is the ASA postulate. If the congruent side is one of the non-included sides, then the reason is the AAS theorem. Either non-included side is fine. It's as simple as that. I won't spend as much time on this as I did the last section, because it should be familiar to you by now. But in a proof, you need to make sure all three pieces, both angles and one side, are stated as congruent before you use either ASA or AAS. Just make sure you are careful in your proof and all three pieces are there. In section 4.2, I made a point to go over that it is important that both triangles match. And in the last slide, I had that odd parenthetical aside, where I mentioned that the matching sides had to be both included or both non-included. This is the reason for that little qualification. You must make sure both triangles match. Of all the 5 ways to prove triangles congruent, ASA and AAS are by far the most common ones that students fail to realize are not matching. So for these triangles, just be careful to make sure they are both the same thing. They both have two angles on one side, but one is the included side and one is the non-included side. That won't work. The left side looks like ASA, the right side looks like AAS. Even though both ASA and AAS prove triangles congruent, they still need to match. Both triangles must be ASA, or both triangles must be AAS. No mixing and matching allowed. This is a very common error, so be careful with it. Other than that, these work very much like the two from section 4.2. That makes 4 ways to prove triangles congruent so far. One more to go.